Okay, we are moving on to the last part of solving two-step equations, and you're going to solve rational two-steps. So rational is anything you can write as a fraction, meaning specifically today you're dealing with decimal coefficients or terms and fractional terms. Now, as you recall from the warm-up, it can get very, very long solving a fraction and a decimal equation. So I want to show you and have you derive some tricks for me. I do not want you to say the pattern aloud. I want you to just observe. So I am going to go through and find each of these products. And I want to tell you there is a pattern. I think you're going to be able to catch on quickly. But just watch and then try to guess where I'm going to be next. I'm going to tell you that 3.04 times 10 is 30.4. Do not say anything. I'm going to tell you that 0.045 times 100 is 4.5. I'm going to tell you that 0.03 times 100 is 3. And I'm going to tell you that 4.32 times 100 is 432. And I'm going to tell you that 1.2 times 10 is 12. And I'm going to tell you that 0.003 times 1,000 is 3. Do you see the patterns that I showed? I want you to. Okay, and what was the pattern? You move the decimal what?
One space to the right for each zero.
Yes, you move the decimal one spot to the right per zero you were given. So when it was 10, I moved the decimal one spot to the right. When it was 100, I moved the decimal 2 spots to the right. When it was 0.03 or times 100, I moved it 2 spots. Goodness. Here I moved it 2 spots. Here I moved it 1 spot. Here I moved it 3 spots. The connection here is you times through by however many spots you want to move the decimal in order to get rid of a decimal. That's what we're going to do all day today. So you need to see this pattern and feel confident with this pattern in order to apply it and be able to get rid of decimals. So here's how you get rid of a decimal, right here. You multiply everything by a power of 10 to make it move. You want to multiply through by however many zeros it would take to move that decimal all the way to the end. That's what you want to do. For example, 0.2x minus 3 is equal to 1.5. How many spots do I need to move the decimal to get rid of the decimal? One spot. So look what I'm going to do. I'm going to times everything. That's why I'm putting parentheses. I'm saying do it to everything. Timesing through everything by 10. Everything. Because when you start changing an equation, you have to do it to everything. That's algebra. Is all about balance. So now I'm going to go ahead and times everything through. And look what you get. 2x minus 13 is equal to 15. And then you can solve like we've been doing. Move what's not connected. So I'm going to move that 30. And you get 2x equals 45. And then divide through by 2. And you get x is equal to 45 divided by 2, 22.5. Much easier than the warm-up strategy. All right, the next one. I have 0.02x minus 1.2 equals 2. How many spots do I need to move to get rid of a decimal? 2. You do the maximum. Notice this one has 1. This one has 2. You want to multiply through by the biggest one. So I'm going to times everything through by 100. 3 things, right? 3 terms inside there. So I get 2x minus What's that next term?
120.
120. One spot would be 12, but I need to go one more. So it would be 120 equals what? 200. And now you can solve as normal. It's much nicer. So I would plus 120, move what's not connected, and you get 2x equals 320. X equals 160. Okay? All right, and the next one, 4x minus 0.2 equals 1.4. How many spots do I need to move to get rid of the decimal? One spot. So what do I multiply by? 10. So I'm going to multiply everything through by 10. 1, 2, 3 things inside. And then I get 40x minus 2 equals 14. Because the 10 is just moving the decimal one spot. And then I will solve. Plus 2, plus 2. 40x is 16. Okay, and then x is 16 divided by 40, right? Because you would have to divide through by 40 to both sides. Which is 2/5. Yes. Okay, so that's the decimal trick. So when you're given decimal equations today, you can go ahead and solve them the long way if you so desire. It takes a long time. It is much easier to apply the decimal trick, meaning timesing everything through by either a 10 or 100, sometimes 1,000, however many spots you need to move that decimal to get rid of it, okay? Okay, the next one, I just want to scaffold your knowledge. If you know what scaffold means, it means make a connection. So remember when we solved this, 3/4 x equals 5. If I didn't want to use the reciprocal, how do I get rid of that denominator? You multiply. So remember, to get rid of a denominator, you multiply. So when I got rid of the denominator, I multiplied everything. Whoops, why did I do 5? I multiplied everything through by that denominator. That canceled that out. That's why we did that. And we got 3x is 20, and then we solved that way. Okay? So same strategy when you're given a two-stepper. If you're given a two-step fraction equation, get rid of the fraction if you want, right away. How you do that? Multiply everything by the denominator, and it will get rid of it. But don't forget everything, because some kids forget to do it to everything. So if I wanted to get rid of my 1/4 and 3/4, what should I times through by?
-4.
4. So I'm going to times everything by 4. Okay? That canceled that 4 out, right? And I have 1x minus, that canceled out, 3 equals 8. And now you can add 3 to both sides, and you get x is 11. Okay, and the next one. What should I multiply through by? 5. Now you got to multiply everything through by 5. So times 5, times 5, times 5. And that gets rid of that 5 on the bottom. So I get 15x plus, what am I left with? 1 equals 5. And then I get rid of the 1. And I'm left with 15x equals 4. X is 4 divided by 15. Remember, you'd have to divide through. And it's okay that it is a fraction. because I feel confident with my algebra. Now, even bumping it up one more rigor level. Sometimes you are given different denominators, darn it. When you're given different denominators, you need to times through by the common denominator. Okay? Because if you times through by the common denominator, it will actually end up canceling them out. So what is the common denominator between 5 and 4? 20. Now watch what I'm going to do and watch how I line this up. Times by 20, times by 20. See how I'm lining it up towards the top? Because it's really 20 over 1. Times by 20. I get negative 40x minus, now look what happens. That turns to a 1. And what does this turn to? A 4. A 4. So this is actually minus 16 equals, that turns to a 1, that turns to a 5, 5. It really does. So now plus 16 to both sides, and you get negative 40x equals 21. X is negative 21 over 40. Okay, let me do one more. I see some scrunched up faces. So I want to be able to get one more down here. So let's do 3/5 x plus 1/2 equals 7. I have no idea what that's going to turn to. But that's okay, we've been dealing with a lot of fraction ones. Okay, so I want to get rid of them. So what is the common denominator between 5 and 2? 10. So I'm going to times everything by 10. It's really 10 over 1. That's really what it is. That's where all this is coming from. So you can cross simplify with multiplying fractions. This would turn to a 1. This would turn to a 2. Top times top, 6x plus, cross simplify, turn to a 1, turn to a 5, top times top, and then equals 70. Then subtract 5, and you get 6x equals 65. X is 65 over 6. Okay. Okay, there's some examples where when we're timesing through, there's parentheses. And I want you to know that the parentheses are really a shield. A shield, like it's protecting the numbers that are inside it. So when you times through, you actually can't times through inside the shield. Okay, it blocks you away is really what's happening. So when I look at this first one here and I want to get rid of my 3, I just start left to right. So I say, okay, I'm going to times through by 3. Oh, these are protected. They're covered up, so I can't times them, but I can times my 4 by 3. So then that would cancel out and you'd be left with 2 parentheses, 2x minus 2 equals 12. And we're going to solve that later in the week. We don't need to worry about solving. I just want you to visualize that parentheses are a protector. They're protecting what's ever inside. So when you start multiplying through, it's protected. You can't get to it. So here I want to times through by 4, right? So I would times the 5 by 4. I would times this 3/4 by 4. Can I times inside here?
No.
It's protected. I'm being blocked away. But I can times the 3. So it would be 20 minus, the 4's canceled, 3 parentheses x plus 8 equals 12. So the summary there, you won't have to solve one like this, not yet. The summary there is that you need to know that a parenthesis is really truly a shield and you can't multiply inside there.